So now that you've looked at how to solve a system of 3 variables using substitution, I'm going to show you how to use elimination to do it. Unfortunately, it is not this nice new shortcut process. It is long and time consuming, very similar to substitution. So you're not really going to get much of a break here. But briefly going through the steps so I can more show you how to use the steps on this example. We'll start again by numbering our equations. That's just going to help us with keeping our work straight. Then what we're going to do is we're going to take I'll start it with the steps I have. I'm going to pair 2 of my equations based on the easiest to use elimination with. I will add those 2 equations together and relabel the result as equation number 4. Then I'm going to do those same 2 steps with another pair of equations. The big thing I have to make sure is that I eliminate the same variable in both of my pairs. Then I'll take my equations 4 and 5, and I will use methods that we've learned or that we've seen and reviewed with 2 dimensions to solve equations 4 and 5. And then I'll use the results that I get from equations 4 and 5 to go back to one of my original equations and solve for my 3rd variable. So let's look at how that works. So first thing I'm going to do is I need to pick some equations. So I notice, well actually the first thing I need to do is number them. So I'll go 1, 2, 3. I notice that if I paired up equation 1 and equation 3, it would be very easy to make my z's drop out. In fact, I already have opposites. I notice the same as 2 of 2 and 3. So I'm going to take steps 2 and 3 along with 4. I'm going to kind of set up the repeat at the same time. And I'm going to say I'm going to add equations 1 and 3. And then I'm going to add equations 2 and 3 because again, those will both make it very easy for z to drop out. And I have to have the same variable drop out first both times. So I'm going to take equation 1. It's really nice. I don't have to change it at all because I know I already have opposites. And I'm going to take equation 3. And now, just like I did with 2 dimension, I'm going to go ahead and add these together, giving me a negative x minus 4y equals a negative 18. That's going to be my new equation 4. And I'm also going to add 2 and 3 together. So 2 and 3. Okay, and when I do, I get 12x minus 12y equals negative 55, and negative 29 is going to give me negative 84, and that's my new equation 5. So now that I have 2 equations, I can go ahead and solve my 2 new equations that I got from 3 and 4. So notice that this was step 3 and this was step 4. Okay, and so I'm going to take and I'm going to solve 4 and 5 now. So looking at 4 and 5, well, I can see that if I multiplied equation number 4 by a negative 3, I would have a positive 12y and a negative 12y. So I'm going to go ahead and say I'm going to multiply number 4 by negative 3. And then I get number 4 becoming 3x plus 12y equals 54. And I'm going to leave number 5 as it is. And I have 12x minus 12y equals negative 84. So notice I'm using elimination here. I could have used substitution if I'd wanted to because it would have been fairly easy to get this x here by itself. Adding together I get 15x. My y's drop out equals negative 30. I divide by 15 and I get x equals negative 2. So I've solved for one of my variables. So now I have to solve for the other one. So I'm going to plug negative 2 back into either of 1a, 4, or 5. So I'm going to say I'm going to plug it back into number 4. So using this equation here, this one right here, I will have a negative 2 minus 4y equals negative 18. Well, that means 2 minus 4y equals negative 18, which means negative 4y equals negative 20. Or y equals 5. So now I've solved for 2 of my variables. So now I'll do my last step. I'm going to take my results from step 5, so x equals negative 2, and y equals 5, and I'm going to plug them back into one of my original equations. It doesn't matter which, and that will allow me to solve for my final variable. So let's say I take and I plug them back. How about into equation 1? Plugging them into equation 1, I get negative 5 times negative 2 plus 3 times 5, this is equation 1, plus 2z equals 11. So 10 plus 15 plus 2z equals 11. Well, that means 25 plus 2z equals 11. I'll subtract my 25, leaving me 2z equals negative 14. So when I divide by 2, I see that z must be negative 7. So I get a final answer of negative 2, comma 5, comma negative 7 for my point of intersection for these three planes. I'm just doing a quick summary. So notice that substitution, just like with 2 dimensions, is easiest with 3 dimensions if you can get one of the variables by itself so you can plug it into your 2 other equations. Elimination is easiest with 3 dimensions as it is in 2 dimensions if you can get one of your variables very easily to eliminate, because you either already have opposites or it's very easy to get opposites. Again, just remember you need opposites with 2 separate pairs of equations, just like I had up here where I had opposites with 1 and 3 and I had opposites with 2 and 3. Or if I don't have those opposites, they need to be easy to get or manipulate through multiplication to get those opposites, just like we need to do in 2 dimensions.